Congratulations on that. And that's awesome. Are you going to travel next month?
It's optional.
To where would you travel?
Just
Cool.
I think you should go.
I also think you should go. Sweet. All right, here we are, law of cosines. Now, I'm going to present this differently than I did last class. Here's the thing. Much like we saw with some of the trig stuff, there are a lot of variations of this. I know that the law of sines says the sine of angle A over A equals the sine of angle B over B, and so forth and so on. We can switch it around, right? This one is uglier. We're going to give ourselves the law of cosines right off the bat, and instead of us trying to derive it, which is a wonderful thing to do mathematically, but figuring out where something comes from is a lot of work that maybe we don't need it. I might have had a change of heart. Let's be redundant here, and we're actually just going to define for ourselves the law of cosines. I'm going to call it LOC, just pure convenience. Okay, so first off, if we have angle, angle, side, or angle, side, angle, or angle, side, side, these are law of sines situations. The other two possibilities, side, 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 or side, angle, side, these are law of cosines. Now, for this, we're going to say given triangle ABC, and I'm going to make this line up exactly with the proof that we're going to do. Given a triangle like this, where we know on this triangle, we're given the lengths of two sides of them, and I'm just going to default to say that these are sides A and C. Just kidding, B and C. If I give you a triangle, and I give you lengths B and C, and the measure of angle A. Now, for this, I'm trying to set this up because we are going to prove it. And we're at least going to walk through it. Whether you could prove it independently isn't my main concern, but if you can follow the proof and see that, yep, I'm convinced that this thing works, I'm good with it. For this, it doesn't really matter for the lengths B, C, and measure of angle A. This is a side angle side case just so we can see it. Okay, so here it is. We get a lovely formula, and I'm going to see if you guys can help me reason out how this works. If I want to find A squared, which notice, that's the side that I don't have. If I want to find this side, or A, it turns out it's A squared, here's what I'm going to do, and this is the way that I remember it. Can you tell me on triangle ABC the two sides that aren't A? B and C, right? So check it out. A squared turns out is exactly B squared plus C squared, but we've overcounted a little bit too much. So as long as you can identify two sides that aren't the one we're after, all we're going to do is we're going to subtract something. We're going to subtract 2BC, note it's the same sides, times the cosine of the angle that matches the side we're after. Blah. Okay. Now, there is a pattern to this, and it can be hard to see. You do not have to write all three of them out unless you want to, but I want to. Up to you if you want to. This is when we solve for A. Now, sometimes you'll see it. If I want to go one step further, what we do with side A here? If I wanted to solve for A instead of A squared, what must I do? Square root. Okay, so there's a pattern that's going to show up. Let's look at it as a different one, and we'll say that here we might be given different stuff, but we're going to be able to pick it out. Can you tell me the two sides that aren't B? A and C. So any guesses on what we might do to these? A squared plus C squared, and I need to subtract something. 2AC times of B this time. Notice they match. Okay, I'm going to give you a challenge, quote unquote. I feel like you're physics authors. Do the same thing for side C. I wind up with C squared equals the two sides that aren't C. Looks like A squared plus B squared. And then I subtract 2AB times the cosine of C. Okay, for this, it is pretty plug and chuggy. Now, This works really well if we're solving for what on our triangle? Like in each of these three scenarios, am I solving for which piece? A side. So I'm going to sneak the word or in here, and then I'm going to underline these and just say, hey, these things are solve for a side. Okay, now that's like half the battle. Literally half the time you may solve for a side of your triangle, and then you'll be able to kick forward. What if you don't want to solve for a side? What's the alternative? An angle. Here's what I want you guys to do. I'm going to give you a little bit of time. I want you to do this in your margins. It's going to be scratch work. Pick the top one, and off on the side, I want you to solve it for the cosine of angle A. Take this expression, have work off to the side, because we're going to write this solve for an angle situation here in a second. I want you to look at this one, and in your margin on scratch work, I want you to solve for the cosine of angle A. I'm going to give you guys a minute. Rearrange with algebra. The cosine of A would be exactly equal to this lovely fraction, b squared plus c squared minus a squared, all divided by 2bc. Questions, concerns, compliments. Okay, so when we're looking at this, this is also going to generalize out a bit, just so you're aware. If I solve for the cosine of A, this is how it shows up. And the way that I remember this, and I wish I had a nice little like tune or something for you guys, I don't. I remember always, if I'm solving for A squared, I use the other two sides. When I'm here, if I'm solving for angle A, I use the two sides and I subtract A. And then I divide by the same thing again. So BC here and BC here. If we want to just generalize without doing the whole work, could you help me do this? What are the two sides that aren't B? A and C, right? So we'll square them. Here's A squared plus C squared. And then since I'm solving for B, I'm going to subtract B squared. And what should I divide by if I'm following this pattern? 2AC. Do you want me to write the third one? Okay, I'll write it just so it stays consistent. It is entirely up to you guys if you want to. So here I am, just thinking out loud. The two sides that aren't C, well, it's A squared plus B squared. I'll subtract that one. And I'll do 2AB. All right. Now, as we look at these, I want you to notice something, and we'll be able to connect it. On this right side, whatever I plug in, do I need to know any angles? So, two things that I want to comment on. First off, these ones are what we'll use if we're solving for an angle. So we'll just say solve for angle. And then the other piece that I want to just really draw your attention to is that on the right side, I'm solving for an angle and I have to know three sides of it, right? This is my side situation on the right half. The left half looks like it better be a side angle side situation. Two ways to look at it, two ways to get it. Okay, we are going to do something different. Last class, when we did this, I tried to get everybody to derive it, which we can see where it comes from, but I think that it felt a little not great. Instead of deriving it, this class, I said, let's switch it. Here's the proof, or here's the idea. We're going to prove it. Okay, here's the agreement with the proof stuff. If you want to write it, you can. If you elect not to write it, I'm fine with it. I'm going to be asking you guys for help as we go through all of this, but I'm not going to make you prove it. I want you to be able to follow it and ask questions if you don't understand something we're doing. When we did this Friday without knowing the end goal, it's hard to try to work it out, is why I'm changing it. Okay, so if we're trying to prove a theorem or a law like this, it says, hey, given this, find this. Check it out. Here's what we're going to be proving. Given, and we'll actually write the proof of this, and I'll move this whole thing down one more little piece. Cool. And that's going to drive me crazy, but proof. Again, you do not have to write it, but as long as you can, as long as your ears and stuff are open, I'm fine with it. So I've given us, on this picture, the nice side angle side case. I gave us a triangle ABC and said, look, we know some lengths and we know an angle. And then all I've done is I've taken that and I've put it on the coordinate plane. Why did I dash that third side? That's the length that we don't know yet. So we may wind up using it, but we're going to make sense of all this. Now, purely arbitrarily, I have elected, because I want stuff to be as easy as possible, I have made point A the origin. Nothing crazy happens there. And then point B, I just said, hey, look, it's somewhere on the plane. I'm just going to call it XY. Everybody okay with what we have in the picture that I presented? I have two side lengths. It depends on what B actually is, obviously. But I can get it. It also depends on where point C is, but I haven't even put it down. Okay. As we roll through this, we are going to do some similar stuff that we did last class, but I want to make sure that everybody can follow along. This triangle is rough, and it doesn't work nicely because it's not a right triangle. If I wanted to drop an altitude or a height of this triangle, based on the way I've oriented it, where would you draw the altitude from? Point A, point B, or point C? B feels natural because it's at the top, right? Okay, so check it out. I've not cheated. We're going to make that even finer. I've not cheated. I haven't done anything. I've just added an extra line to think about stuff. Okay. Everybody okay with we now have a right triangle showing up? Okay, we're even going to get crazier. If I wanted to label this side, what side length would I call it? I don't know its length yet. A. All right. Everybody's still cool. Now, furthermore, I know that this whole bottom side is B, right? However, from this altitude, from point A, I just have to work to the right. How far to the right have I had to work to get here? I've had to go X units over. And I know that that's true because I go from 0 to X. Everybody's still on board here. Okay. Very similar to what we did last week. I've changed a couple little letters, and we're doing it. We're just proving it. Okay. So first thing that I want is, man, I'm going to call this Y temporarily. I'm going to focus on a lovely right triangle to try to make sense of this. And I want you guys to help me with any right triangle that you can use to make sense of this. We're going to make a couple notes. If I wanted to take the sine of angle A, I have to be working with a right triangle right off the bat. Am I working with the left triangle or the right triangle if I'm trying to find the sine of angle A? The left. It has to be, right? This does not have angle A on it, on this triangle. Okay, so let's see. Sine is what over what? So opposite over hypotenuse. Everybody agree that that's Y over C. Okay, one little step. I'm just going to say, okay, well, I think that C times the sine of angle A is a way that we can write Y. Cool. Could we do something similar with the cosine of angle A? And let me rephrase that because that's a dumb yes or no question. What would the cosine of angle A be if we're looking at that left triangle still all the same? X over C, which will take us to C times a cosine of A must be equal to X. Everybody still on board? All right. So everything here has been left side, the left triangle. We are in agreement. I need to get somehow only following this, because all we've done right now is we've said, here's our givens, and we've done a little bit of scratch work off on the side. This is where I need to wind up. If I want to get an A squared, which triangle should I use if I'm trying to think about regular old trick stuff? Left triangle or right triangle? The right triangle, because it has the side A, right? So let's just do a little digging. I need to get A squared into my proof because this is the very last thing that we need to write. So let's try it out. If I now focus on the right triangle, I don't know how I changed the size there so big, but let's check it. Only looking at the right triangle, what is A squared? How would we write this out? I know that it's this squared, right? Which, what do we call that? That's Y, okay? And I'll leave that one second. And gosh, this side also though, right? We didn't label it. However, if this whole length is b, if we take x out of it, is this b minus x right here? So we're going to use that. We're going to say, okay, just using Pythagorean theorem, a squared is just b minus x squared plus y squared. And it's ugly, but can you guys see that this is indeed true, and it's just the Pythagorean theorem? Have I lost anybody? Why b minus x? Can somebody explain that to me? Talk with your neighbors. I'm going to call on somebody random. Why is this b minus x right here? Of that right triangle. Okay, I'm good with it. Now, here's the cool part. Once we get here, I don't really love x's and y's because we need to get all this crazy stuff in here, right? What did we say x was just a second ago? B minus, this looks like c times the cosine of a. That gets squared. Plus, what was y? C times the sine of a. And what happens to this one? Dang it. I was already just rolling. It also gets squared. All I've done is use these to replace x and y. Okay. I'm going to do what next? Where would the algebra take me if we had no idea what to do? Exponents. And we're not freshmen, so we're actually going to FOIL it out. I'm going to save us a little bit of time. I think that when we FOIL this, this is going to be b squared is my first term. Which, notice, that's looking pretty good. I'm happy with that. The next one is going to be uglier. It's going to be negative bc cos a. And then another negative bc cos a. So that's negative 2 bc times the cosine of a. Everybody cool there still? And the last, this times itself. C cos a times C cos a. C squared cos squared a. And how about this last term here now? C squared sine squared a. All right. We're going to take a second. I'm going to underline some stuff. I wouldn't do it on yours unless you really want to. And again, you don't have to be working it out. That whole piece just foils out to that. That's all I've done. Okay. We are trying to get to this. I'm saying from this given information, I want to end here. Help me out here. How can I rearrange and change something anywhere in here to start getting toward this? I can factor out a c squared from these two terms. I like it. Let's do it. So here we go. I will replace all of this. B squared minus 2bc times the cosine of a. And plus, and I'm going to use your idea. Love it. C squared. And what stayed inside? Cosine squared a plus sine squared a. Huh. Well, we're close. I know that I can take this c squared and all this mess, and I can move it here so it looks like it should. But there's one more little piece just hanging around here saying, hey, do this now. What's the hey, do this now? Something triggy. Cos squared plus sine squared. What is that? That's a 1. Which means realistically I don't even have to have it. Can I now say that this is just c squared? And I could rewrite everything with just this gone since it's a 1. But I could also, I think, just move this around. Because I can move the way that we add stuff. So here we go. Big moment of truth. B squared. I'm going to put the c squared right here. Still times 1. And then what's the only thing that's left? And look at that. From side angle side given to me, we just found that this is, in fact, the formula that does work. Now, huge difference from what we did the other day. I was trying to make you guys just find it. It's ugly. Like, to try to make sense of what's happening without knowing where you end up, it doesn't make sense. That was a my mistake sort of thing. The proof itself, is it super ugly? Kind of algebra-y, but is this nicer than 2-column geometry proofs? This is way harder than a 2-column geometry proof for what it's worth. Now, do I expect you to be able to prove this every time no matter what? No, this is not a proof class, but it's nice to see that even if you would never come up with this, and that's okay that you wouldn't, if you can follow along with it and you see what's happening, that's a big step in math. All right. Feel all right with this? Cool. Let's do some problems. I'm going to try real hard not to give you guys homework because I know you have a lot of stuff to do. And y'all look kind of tired. All right. Let's get wild here. I am going to leave it up to you guys. We have a way to solve for a side. We have a way to solve for an angle. I only ever remember one. On my cheat sheet, my note card, I would put one of these. Maybe one of these. As long as you recognize the pattern, they're easy to get to. So let's check it out. We're going to throw total wrench into the works. Okay, here we go. I give you a triangle. A triangle has lengths. And normally they just present them as, hey, here's 3 lengths. But I'm going to give us letters to make sure that we have them. Let's do something that's not ABC. What's your favorite letter, Abigail? Z. Okay. We have length Z. And I'm told that it is 12. We have length T. And we're told that it is 8. And I have length, I don't know, Q. And I'm told that it has a wonderful length of 6. Okay. I want us to solve for a triangle. What's the name of my triangle? ZTQ. QTZ. I don't care the order that you give me, but there it is. We are looking for this triangle. Okay. Right off the bat, the very first thing that I would advise is I have not looked at this triangle. You can try to sketch it if you want to, but your sketch is not going to be super accurate. I won't always do this, but I would almost say don't draw the triangle, because if you draw it and you draw it funny and now your brain's connecting this with a certain type of triangle, you're more likely to make mistakes. Okay, first thing I want to check. Can we identify what the longest side of my triangle is?
12.
Good. I'm going to double check to see whether or not this thing is a right triangle. Because if it's a right triangle and I try to do law of cosines or sines, I'm just wasting my time. 6 squared is 36. 8 squared is 64. Those sum up to 100, which square is 10. Square root is 10. Is the third side 10? So it's not a right triangle. Pythagorean theorem just failed. It is not a right triangle. Okay, I didn't show it. We just thought it out. If you need to show it, you can. What am I given? And I mean angle, angle, side, angle, side, angle, angle, side, 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 angle, side. We are given side, side, side. That is my first little piece. And obviously, we're going to use something. Side, side, side implies which law should we use with side, side, side? This is time to lock in with the law of cosines. No smirks. I think that's a pretty good wordplay, but that's all right. I enjoy it. Okay, we're trying to solve for an angle. I don't care which angle we start with. Doesn't matter. Pick an angle, JV. Z. Okay, now the one thing that I don't do in the formula, and some books do, some books don't, when we rearrange it up top, we solve for the cosine of A or B or C or Z, whatever, right? I did not go the last step. You would do one more step once you write it. You'll take the arc cosine. I just think it's nicer without having that on the page. So let's try it out. I'm going to just start in. We're going to find an angle. So let's see. I know that I need angle Z in the end. I'm fine with finding that one first. I know that the cosine of Z is equal to, can you tell me the two sides that aren't Z? 8 and 12, are you sure? T and Q are the two sides that are not Z, right? So I'm going to take them and I'm going to do a fraction here. What do I do with those sides t and q? Like there's something wrong with this. We need another little symbol. Check your formula if you need to. We're going to, so I have the cosine already. They need to be squared. Side that's not z squared plus the other side that's not z squared. And then I do have z as well, but I subtract it. Squared. Okay. Once we're here, we divide by 2, and as long as we've done stuff correctly, I can already see the numbers. What's the first number up top? 8. And the second number? 6. Boom. Okay, I want you guys, everybody to have a calculator. Did you bring your calculators back, by the way? Yes. I got one answer. Okay, I want everybody on your calculator. I would suggest first time, try to do just the numerator, then do just the denominator, and then we'll sort everything out together. No, it's going to be negative. It's okay. Is it negative 44?
Yeah, first, yeah.
Oh yeah, 44.
Okay. So I get negative 44, and I'm going to rewrite my cosine z here. Cosine of z is negative 44 over what? 96? Okay. Everybody on board here.
Yes.
Okay. If I now want to solve for z, I can't divide by cos. Cos, that doesn't work. How do you undo a cosine? You,
Sine.
I don't agree with arc sine.
1 over.
Arc sine would undo a sine. Hey, let's use the arc cosine. So I will take that arc cosine to the left, leaves me with angle z, equals the arc cosine of negative 44 over 96. Okay, I'm expecting 2 different answers. Don't change anything right now. Once you get an answer, shout it out loud and proud. I'll write them both, and we'll see which one makes sense. 117.0 frick. Okay, there's one. 96.57.
What? So 2.04.
2.04. All right, we're getting wild and crazy.
Okay, then I was right. I learned it.
Time. Did we specify whether we wanted degrees or radians? No. Either is fine. What do you think is more standard for doing law of cosines or sine stuff? Degrees is more standard here. It's irritating. 117. Can somebody second that? Okay. I'm going to say 117 point what? 28 degrees. Okay. At this point, we have a decision to make. Okay. I was given 3 sides, and here's one of the angles. I need to get another angle, right? Now, you have to be careful with this. At this point is where, if I were going to draw it, I might think about it. Realistically, I would prefer to just use the law of cosines again, but I want us to think about what we have. 12, and let's see, angle z must be opposite of my longest side, so it's going to be over here. So 117, maybe my triangle looks something like this, where here's my 12, here's my 8, and here's my 6. And I know that it's obtuse, like we just found that. Now that I know that I can sketch a triangle. Okay, here's what I want us to think about though. As soon as I get that, and I have my angle here, 117.28. If we look at this triangle, here's where my mind goes immediately. I have that information given. Could I use the law of cosines again to get another angle? Like I still know all 3 sides, I just rearrange a formula and I have it. Do I have another option if I don't want to use law of cosines again? I could use the law of sines here and it works fine, but you have to be really, really careful. Because if I'm trying to use law of sines, I know it's not angle, angle, side. It's not angle, side, angle. The only option is to do these 2 sides with the angle or these 2 sides with the angle. The angle side case of law of sines is weird. It brings up the possibility of what? We call it the, I don't like the word, I'm going to use the nebulous case, but there's a different word that shows up. The ambiguous case. Do you guys really want to have to deal with the ambiguous case here? No. So to avoid that, you could use law of sines, and maybe it'll be faster. I'll tell you, if you check your sheet and look at the obtuse situation, there is no two triangle case for the law of sines with obtuse angles, which is nice. If we don't want to use the law of sines, let's use the law of cosines again. I'm just going to erase this. You're cool to use the law of sines, but always check for that ambiguous case. Okay, what angle do you want to find then? T. So I'll write it here. We're going to find angle T. And check it out. The cosine of T, I want you guys to finish this off. Use the law of cosines. Find me angle T. Ferd might already have it. I can't tell. I'm going to come just chat with you. Can I see your bell ringers from last week? I think
I have the one from.
yep. I know you only have one. I just wanted to get you did it while we were here. So, love it. You found the second one, right? And then you just bother me just on this one via subtraction. Yeah, got it. That's what I'm hoping for.
It's just the one from.
It's not.
I think we did Tuesday, but that's fine. Will you do me a favor? Will you go back and do T using the law of sines? So Z over the sine of 117 equals something. I'm so glad you guys got back today. You were going to be out another week if you didn't. Did it work with the law of sines?
Like that.
Or are you doing it? Yeah, I don't have a reason to not trust people in here. Abigail, did you do your bell ringers last week? Did you do the one from you were in class?
Yeah.
Did you? JB, did you do bell ringers last week in class when you were here? The Tuesday? Okay. Charles, did you get your bell ringers? Mickey?
Yeah.
Did you really?
What happened?
Why? Did you do your bell ringers when you were here last week? Okay. Are you guys getting funny answers?
Well, we're just, because last time it was negative, and then we had, it was positive.
So, and that's okay because remember that cosine, if I'm here and I go down here, I still get a positive. Like, even if it's like, we're going to get the right angle out of it. It doesn't matter there. I'm just going to plug in all these sides. So let's see. The two sides that aren't t are q, right? Z squared plus q squared minus t squared all over 2z q. Like, without even thinking, I know that this is what the letters have to do. Which I don't love the math where you don't have to do a lot of thinking, but hopefully you guys do because this is just plug and chug. Cool. Do we know all these lengths? Okay, so let's see real quick. I lost my side lengths. Z is 12. What's Q? 6. So that must be minus 8 squared over 2 times 12 times 6. Okay, when I do this, and you are welcome to if you want to on your calculator, I don't really care if you do top, get an answer, and bottom and get an answer. I would encourage everybody to try typing this into your calculator with or without the arc sine or arc cosine. I would literally just type this into my calculator. I would type key for key, arc cosine, and then I would do 12 squared plus 6 squared minus 8 squared. Close it. 2 times 12 times 6. This is key for key what I would type into my calculator. Yep. Arc cosine, and then I would put the numerator in parentheses, divide by the denominator in parentheses, and I would finish my parentheses at the end. And when I do this, I get angle T is approximately, I don't know the answer. 36.33 degrees. Anybody get something wildly different? Can you guys type this in one quick swoop? And you got that? Good. If you can't do it in one quick swoop, is that okay? For sure. Like, do it in 2 lines like I did on the first one. Do we need to use law of cosines again? No, I don't think so. Why? Well, golly, yeah, I just take 180 minus 117.28 minus 36.33, and we wind up with this fantastic green angle, which is R, right? No, Q. And I'm not good with decimals in my head. I don't know what this is. That's what I was going to say. Wait, 39. Yep. 28? 38?
No, 26.
Okay, everybody's. Let's.
26.
Will you read me your answer, Kalisha?
26.38.
That's what
I think, isn't it 39?
I said 39 because I included the decimals.
384.
The decimals from the.
Well, if I do 2 decimals, it better be 39.
No, but the other.
Oh, okay, I
next.
get it.
Okay. No, wait. That's
Because these add up to n in a 1.
I kept the decimals from at least one. From one.
Okay, deal. If you're off by 100th of a degree, am I going to destroy you?
Yeah.
Yes.
That, you know me. Cool. Doable?
Wait, how did you already take Q? Because
You guys just gave it to me. 180 minus 117 minus this. All right. I'm not going to give you a formal assignment, but I have one more problem that I want you to do. Here we go. On the example, and this should have been B, but here's what I'm going to tell you. I give you angle R. Measure of angle R is a calm and cool 75 degrees. And side V is, I don't know, we'll say 12. And side R is 10. I want you to solve for me triangle. Wait, hold on. Time. We're going to make this an N. It's easy to fix. I changed this R to an N. So that means we need triangle RVN. Raven. Cool. I'm going to give you guys a head start. This solution is the only thing that's going to be shown. It will not be talked through. It'll just be the answer at the very end. Hopefully you're watching this, Rafa. And here is the detailed work for that last problem. No homework tonight.